A little bit of time. So it says sketch the graph of each of the following functions. On your sketch, identify any intercepts and or asymptotes. So what we're going to have to do here is I'm going to start always with our parent function, and then I'll graph these others. Okay, now I'm going to show two different methods for this. The first method is using the first method is using the original graph and then translating all of the points. The second one is using the mapping notation with individual important points. Okay, so first thing, we are going to make a set of axes, and we're looking at the absolute value of x. So if we look at the first function, or the basic function of the absolute value of x, that's 0, 0, 1, 1, 2, 2, 3, 3, negative 1, 1, negative 2, 2, negative 3, 3. Right? Hopefully you remember that from class. And then it goes basically out like that and out like that. Okay, so that right there is y equals the absolute value of x. Well, what we are going to be looking at is what the plus 1 here and the plus 3 here do. And the plus 1 makes it move left 1, plus 3 makes it move right 3. Okay, so if it's moving left 1, right 3, sorry, left 1, not right 3. Yeah. It's going to make it go up 3. Sorry. So left, so this point here is from the middle, left 1, up 3, new point there. 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 Left 1, up 3, you get the idea here. You're going to get all of these points there, and then when you graph that new function, that's what you get. Okay, this is y equals the root, or sorry, the absolute value of x plus 1 plus 3. Okay, second thing, x, or the root of x minus 2 minus 4. So I'm just going to draw in another set of axes here. Okay, now remember the root function is going to be 1, I'm just going to move it over this way. Sorry. The root function is going to be one where it starts with 0, 0, 1, 1, 4, 2, 9, 3, and then it's kind of like a sideways parabola. So then what we're going to do, again, we're going to look at and see what does this minus 2 and the minus 4 do. So the minus 2 makes it move to the right 2, and the minus 4 makes it down 4. So we're going to take all of those points and we're going to move them. So this one, right 2, down 4. 1, 2, 3, 4. That's our new point. This one, right 2, down 4, new point. This one, right 2, down 4, new point. This one, right 2, and it's going to be off the screen. So then, connect the dots, which is my favorite part of math, and there's your function. Okay, so we had the original function, and now we have y equals the root of x minus 2 minus 4. All right, we'll do the next two a little bit lower. So y equals 1 over x plus 6 minus 4. A little bit trickier, but still not super tricky. Just need to know what the original function looks like. And we're going to start with that original function, which is y equals 1 over x. If you remember, there's a couple critical points here at 1, 1. And basically, they're just going to asymptote out like that. Right? Remember, there's asymptotes everywhere. So I'm just going to draw them like this as a dotted line. Okay. No, I guess I forgot something. It asked on your sketch, identify any intercepts or asymptotes. There were no intercepts in, there were no asymptotes in either of these cases, but this is an intercept here, and you would notice an intercept somewhere a little bit further along, which you could figure out what that would be if you really wanted to. Okay, but in this one here, we do have asymptotes at y equals 1 over x. But we are now looking for the question, or for the graph of y equals 1 over x plus 6 minus 4, I believe. Yes. Okay, so when we graph this, we are going to look at, well, what, this one we're going to use, it wouldn't be very easy to use mapping notation, but what I will do, I'm going to map these first 2 points for you, so that's the point 1, 1, and -1, -1. And so first we need to know what these values do. So what does the positive 6 do? What does the -4 do? So the positive 6 moves it left 6, the -4 moves it down 4. So we're basically saying that any point xy is going to map to give x minus 6, x minus 4. Okay, so then we can take our point, say 1, 1, map that to being 1 minus 6, 1 minus 4, which would really be -5, -3. And we can take our other point, -1, -1, and map that to being -1 minus 6, -1 minus 4, which in turn will end up being -7, -5. So then we can put those points in, right? So at -5, -3, 1, 2, 3, 4, 5, 1, 2, 3, boom. That's the 1 point, and then the other point, -7, -5. So that's actually these points right here. So these original points, 1, 1, and -1, 1, have all been shifted left 6 and down 4, which is really going to also move our asymptotes, which are going to be, lining up right here and right here. So then when we go to graph our function, it ends up having these asymptotes of, it's going to have asymptotes at x is equal to -6 and y is equal to -4. Okay. What's interesting is that the asymptotes are the exact same as the translations. So since it moved left 6, then you end up having the vertical asymptote moving left 6 units, right? So that's 6 units right there, moving from the y equals 0 to the x equals 0 to x equals -6. Same thing for the horizontal asymptote. You end up having y equals 0 translating down 4 units to being y equals -4. Okay, now that one's a little bit more tricky to do. And I'm just going to leave the exponential one for you to do if you want, just for time's sake. All it's going to do is move to the right 2 units and then down 1 unit. Okay, so last question here. It says for some function y equals f at x, the domain is x is less than or equal to 3. It's a real number, and the range is between -5 and +5. So if g at x is equal to f at x plus 10 minus 2, then that means every single x value and y value are going to change. So if we start as, we could really graph something here. It really wouldn't, it might help us understand this. So domain is x is less than -3, less than or equal to +3, sorry, not -3. So that's like here and going all the way to the left, and then between -5 and +5. So let's say it does something like this, right? And it just keeps going on and on and on and on and on. But we stop it right there. Okay, so this is a point, and that could be our function. So this is -5, this is +5. But now what's going to happen is we're told that we are going to have to do something in the x coordinate and something in the y coordinate. So if we look at this in terms of function mapping, this x minus h here is equal to -10, which means it's going to go left 10, and k here equals -2, so it will go down 2. Now, when you look at the function mapping, that means every xy point will turn into a x minus 10, y minus 2, which is going to change all of our values. So we can take this 5, move it down 2 to being here, this -5 going down here to -7. and then the x, we're going to have to go to -10. So we're actually going to have to move this thing way over here to start at -7, right? So that's going to be way over there. So the same shape is going to happen though, right? So it's just going to start at a different point at -7 and keep going up a certain number of units and then down a certain number of units. So this point here would actually move over to right over here, and then it'd go up to the left, up to +3, and then all the way down to -7. So really, we could try to draw this, and it gives us somewhat of an example. But the mapping here helps us to understand it a little bit easier. So whenever you see something in the x in the domain, really we can say, well, the domain then is going to be x such that, you know what, I'm just going to say x is an element of real numbers such that x is less than or equal to -7. Okay, and the way that I got -7 is just by saying, well, it's 3 minus 10, right? So if this value up here was 3, then I'm going to take that, I'm going to put the -10 in there, and I get out a -7. If I do the exact same thing with the range here is going to be y is an element of real numbers such that -7 is less than or equal to y, which is less than or equal to 3. And again, I got that from taking these numbers of -5 and +5, subtracting each of those by 2, and I end up getting these values of -7 and +3. Okay, so hopefully that helps. I would like you to make sure that you can try this on your own, but use this as a reference if you need to. Okay, thanks.